This is about EU projects. Projects come and go, but we have some design criteria for this project that I hope also are of interest for the rest of you. So this is the project called Arctic Passion. It's one of the last funded Horizon 2020 projects in Europe. You get it in full screen, or?
It said that it wanted to enter into full screen, but it's giving me. Let me try it again. So here, let's do this.
You close that panel to the left and make it view.
We'll go to full screen mode, and now that'll do it.
Yeah, and now it works, I hope. Yeah, yeah. So I lost it here, but now I have to look a bit here as well. So the title, also within the Arctic Passion project, there is one work package dedicated to data management, and the title of that work package is Bringing the Arctic Data into Action. And the reason why we think this is a bit interesting is that we have a lot of data, but that data is of interest if you can link it to a value chain. So if you can link the data into a decision support process, that's the critical aspect of having data. Quite often we rely on the sort of human intervention, pulling data out of the data storage, manually changing it so it fits into a value chain. We try to make the computers use it, and that's why the previous presentation I gave in this morning about semantics is so important, because without the semantics, we can't rely on the computers to help us to put the data from the storage and into the decision support situation. So the focus we have is to improve, because we are talking about availability of data. There's a lot of data that is available. We are talking about preservation of data, but we are focusing quite a lot on the interoperability of the data. How do we make data talk together? And the focus here is then on accessible and analysis for the data. So how do you put the data into the system and make it available for the software to actually work on it afterwards? So there will never be only one data center in the world, and there will never be only one way of data. But the problem we have today is that it's up to each scientist how they actually document and publish data. And that prevents efficient reuse of the data in the longer term. So we would need to at least reduce the degrees of freedom in the data management system, cost efficient and possible to build services on the top of the data. So what we try to do here is to link decision support systems and data. We want to use computers to help us do the work, and we want to harmonize data to machine actionable forms. So how can we also help the scientists or the data providers to generate data that is easy to use? There will be a presentation by Matthias afterwards, after the break, that goes more into a dedicated part of this, also from the Arctic Passion part. And instead of starting yet another project with yet another data catalog, we try to build on what we've been doing before. So what you will see here resembles what Lara mentioned, as I showed earlier today. It's the same toolbox we're using, the scientific information system. We are now also using that in the same context for this same data catalog. It's the same system we're using for WMO, Global Crash Watch, and also for the Svalbard Integrated Arctic Observatory System. And it's not something that is built by us, but it's pieces of software that we put together, and we can switch out some of the components over time. So, for example, both for the Arctic Passion here and some of the other projects, we are actively contributing to, for example, OSG or open software developments, instead of inventing our own software and trying to do everything on ourselves. It costs us something, but in the longer term, I think it's more beneficial for the community as a whole to actually collaborate with other communities. And so the thing on the left-hand side is probably of no interest to you. It's basically the tasks in the project. But the thing on the right-hand side is probably of some interest to you, because what we try to do here is to follow the value chain from the data all the way down to the decision support application and the users that are actively using it. And when we say decision support, it can be a Jupyter notebook, it can be a GIS system, it can be your Excel spreadsheet, for that sake. We don't know. But we have to prepare for computers to help us in this process. The probably interesting part that you can see on the task list is that we've got some dedicated work packages that we are focusing, for example, on transformation of data into standardized forms. So common separated files or spreadsheets are good, but you can't build services on top of that. You need to do something more. You have to make them semantically consistent, or you have to put them into a framework where it's possible to add services on top of that. We also have a dedicated task, and this is probably known for most Europeans, but probably not the rest. In Europe, we have the Copernicus services. Those are operational services set out for the European Union. And we are tasked to set up an Arctic window of the Copernicus services, for example. So these are operational services that we can pull directly into decision support flows. And then there are things on the fair data service provision, long-term data preservation, etc., that we will come a bit back to. So how do we do in this context? First task, mapping the Arctic data system. When we set up the project, we dedicated resources to help the work that is already being done by, for example, the joint SEAN-IASC Arctic Data Committee. We have the Polar to Global online hackathons. We have the working groups with the polar search. We have the polar semantics working group, etc. And there is dedicated resources in the project to support those activities, because without that kind of support, then these activities don't have any funding, basically, to sort of continue. So that's an important aspect of what we try to achieve. We are also dedicated to support the mapping the Arctic data system. And for us in the project, this is a vital piece of information, because if we want to build this as a support for decision support systems, we need to know how the relevant data centers in the Arctic behave. Do they have services that we can actually consume? Do they have nice interoperability interfaces to the data? What can we do in this context? So this is a joint effort between Arctic Passion and also with the communities in Canada, and especially CCADI. And there is matching funds for the European project in Canada in order to support this activity. And then we also try to do coordination with existing data management bodies. So this is the same thing that I mentioned earlier. We are focusing on, one thing is getting scientific data into the workflows of, for example, the World Meteorological Organization. But another thing is getting data out of WMO and making it available for the science community. So both ways are equally important. If you give something to a community, you should get something back. And all the information exchange within WMO is a closed community now. So what we try to do is pull out information, reformat it, and dump it into a form that can be consumed by the science community as well. So it's not a closed information flow anymore. The illustration on the right-hand side here is just taken out of the mapping activity. And there's continuous updates of that now. And there will also be a presentation later in the conference on that. Our data management plan, all projects in Europe is required to have a data management plan. And I think that's the same in many other places in the world. For us, this is both capturing the information that we are generating in the projects. Whenever we set out instrumentation in order to close gaps, etc., we capture that in the data management plan. But another important aspect of the data management plan is, for example, for Arctic Passion, that is setting up a number of pilot services dedicated to serving the community. Which type of information will those pilot services use? So we are capturing that in the data management plan as well. That is not data that we are generating, but it's data that someone else is generating. For example, the Copernicus services. There is a dedicated task, as I said, on the transformation of data to standardized forms. The illustration on the right-hand side here is from that software development. Don't go into details at all on this. Matthias will do that later. But the whole idea is to take any generic format. It can come from a logger, it can be a comma-separated file, and generate a CF, not CDF file out of it. once we have a CF, not CDF file, or a Darwin core archive or something like that, we have a semantically consistent document that we can actually do something with. If we just have a comma separated file, it can be anything in there. It's just numbers. Or if it's numbers, it could be something else. Another task is on the Arctic window of Copernicus. And the first thing we did there's a number of Copernicus services in Europe. And when Copernicus was initiated, it was said that it was supposed to follow the INSPIRE regulations. And we've done a survey of all the Copernicus services and tried to find out the interoperability interfaces of the data. And efficiently, there is a lock-in of all the Copernicus data into various platforms. So this is part of the work that we've done now. We've set up the evaluation of the existing interoperability of the Copernicus services, and we are capturing our own perspectives of how it should be in order to integrate those data into the decision support systems that we are working on. And they are developing some documents for that purpose. So this is the current evaluation we have on the Copernicus services and the problems, and this is quite common for the Copernicus services. There are different approaches to data granularity. So how do you define a data set? Do you have a metadata record per data file? Do you have a metadata record per sort of high-level data set with like thousands of files? And then you have to navigate through the interfaces to each of those data files. There's a lack of standardized interfaces. Many times it seems like the community thinks that if I develop something, it's a standard. So using standards is actually looking around, using either a community-defined or in this industry-defined standards. I'm not inventing your own thing. So REST is not a standard as such. It's not a standardized interface. And this makes it very costly to integrate data into decision support systems because the degrees of freedom is too many. And for the Copernicus services, there is no unified data. So you have to go to each individual service to find out which information that is relevant, and then it's practically locked in to a platform. And what we've done is now to put out some of the ideas that we have and put it into the Arctic Passion perspective on the Arctic window of Copernicus. And this goes hand in hand with a common effort in Europe now with the thematic knowledge hubs that is being developed for all the Copernicus services. You have a coastal hub, you have a polar or an Arctic hub that will come now, and there are a number of other ones as well. And it looks, there is this document is our attempt to try to influence the future development of the Copernicus services at this level, to make it more useful for us. When it comes to the fair data and service provision, it's the same with a number of the same appearance as you've seen before. We are using the SAN data portal, and there is links in there for how to connect your data center to that. It's basically relying on a number of interoperability interfaces. There is a specific guidance material for Arctic Passion projects on how to do publish data. And the recommendations we have is actually to use the Darwin Core Archive or CF.CDF, because those are, as I said, semantically consistent. Yeah, this is mentioned now on the data documentation. What we try to achieve is to have actionable data through web services. So not only dumping data, but actually having services on top of the data. It can be a web mapping service, it can be OpenDAP, in the future OGC, EDR, or something like that. Once we have those services, we can build higher order services, pulling data from different data centers. If we need to copy all data into a central server and do some tweaking of it and sending it out again, the housekeeping is too much to make it work in practice. There's a list in the site of the data centers that are currently being harvested. Schema.org centers are not listed here yet, and that's also quite interesting. Schema.org has a large number of degrees of freedom on how they actually set up the schema.org and how they can convey the information. So the information in itself is not a challenge, the transport mechanism is so difficult. So most of those are relying on the traditional standards like OAI, PMH, CSW, OpenSearch, etc. And then we have schema.org coming quite soon. This is how it looks. I won't go into this. You saw it earlier today, and Jonathan is standing. So, I will just skim through this. But it's what we can do once we have the actionable metadata in there with actionable data behind it and services behind it, without actually having WebNav service access, without having the OpenDAP access. We can't do the on-the-fly visualization of the data and pulling it into the decision support systems. This is just the web mapping service, and web mapping service is kind of interesting because if you're publishing like satellite remote sensing data, it's good. If you're publishing a numerical model, you have to take some care when you publish your web mapping service, because you can't mix, like many people do, you can't mix different coordinate systems within the same data files. Then you mess up the interpretation of the data, because if you want to go up and down, for example, in the height, you are using one type of vertical coordinates and not mixing vertical coordinates in it. So this kind of thinking through how you define a data set is quite important. Or do you mix dimensions? Do you mix different types of coordinates, etc.? That's actually makes it challenging to interpret the data and reuse the data afterwards, and probably more or less impossible or too costly to integrate them in a support system like this. Number of data centers we are currently either harvesting actively or in a dialogue with or attempting to set up services for. And then next steps, I don't use too much time on that, but rather jump into the aspects. And I've used the illustration on the right-hand side for quite a while. When you're working with distributed data management, and honestly, what we try to do in Arctic Passion and in many contexts, it was the same for the International Polar Year. We want to integrate data across data centers. And then we need to think about metadata granularity, so how we define the data set. We have to think about the terminology and semantics and the interoperability protocols. If we just dump data like we put a book in a bookshelf, we can't do much at the other end of it. So we need these higher order services. And where I would really welcome a dialogue is on terminology and semantics, because it's lacking to a huge extent, but also granularity. So how do you define a data set? And for each discovery metadata record you link to one file, two files, or to a service. If you have one discovery metadata records, you have thousands of files in a folder. It's almost impossible to build any service on top of that. But if you have this, also if we are using the discovery metadata as the guidance into the data, it has to be a match at the granularity aspect there, also perspective. And I'm happy to discuss that with people during this conference and after the conference. Coffee?